The final example for increasing and decreasing is an example I wanted to give you where it's going to be a combination of paper and pencil as well as using technology. And what I would hope I would see my students see. So you can see here I've graphed it. Now on the Inspire I can go ahead and name it. So you should be able to see it's going to be increasing to here, then it's going to be decreasing to here, and then it's increasing there. Now we're going to practice some of our skills, or some of our mad calculator skills. So okay, now remember on your Inspire handheld you just have to hover over it, and then you just have to hit your addition symbol a few times, but it doesn't work that way on the computer. So, I know I make this look easy, but I do this a lot. Now, but I want my young adults to use calculus, not just a calculator. Yeah, if this was a calculator part of the AP exam, I could derive everything from there just with conceptual knowledge. However, here's what I want my students to do. Okay, so f prime of x is e to the x plus cosine x. Hey, you know what? Let's check that. Oh, we better add a calculator, and I'm going to go to menu. We're going to go back to calc class. We're going to go derivative of x with respect to x, and we will just put f of x in there, and we'll verify that we get the same answer. All right. One of the things you need to be able to do on your calculator is find zeros and such of that nature. Now let's think about the logic here. This is a sum of an exponential and cosine that exists for all reals, so this exists for all reals. If it exists for all reals, it exists everywhere on the corresponding open interval. All right, and even the closed interval. Now I'm going to go f prime of x is 0. Oh, but Mr. Isaac, whoa, wait 1 second. I want you to show me that you can take the derivative, but you know what? When you're working on the test, I also know we as people make crazy, silly mistakes. So one of the things that I would hope that my teenagers could do is come up here. We're going to use the math tool. We're going to take the derivative with respect to x. We're going to graph this function. Okay. Now, notice how these zeros match up with the max and min. We have 2 of them. That's a good thing. We're going to go to the analyze graph. We're going to go to 0. Mr. Isaac, it's not letting me do it. Now it's because I have 2 graphs. So you select the graph. Boom, boom. Now I'm going to let my teenagers just only check this. Just come over here and adjust it a few times. You know it's 0. I want you to see that. Now menu, we're going to analyze our graph. We're going to get a 0. Select your graph. Okay. But Mr. Isaac, it's different. Well, it's because you only have 2 decimals of precision. But as you add more, notice it becomes the same. All right, so what do we do on our paper? You're going to write f prime of x is 0. You're going to draw an arrow, and you're going to okay, and then on your paper you write this. All right, we're going to make a sign chart. Now what I want you to do is you're just going to come over here and you're going to, hey look, I'm going from -6 to +3. I've got this. I'm only going to go to 3 places because that's what they want on the AP exam. I could, 1746. Okay, now I'm going to go to the graph screen. So from 6 to here, it's positive, then negative, then positive. So positive, negative, positive. And now I'm to justify. Okay, f is increasing on the open interval from -6 to that first critical value, or the second critical value to 3. Now justify it. Why? Because the derivative is positive on, and just copy your intervals. f is decreasing on negative 4.703 to 1.746. Why? Because my derivative is less than 0 on, I copy the interval down. Oops, I almost copied the wrong interval, and see, that will happen to somebody. We all do it. Okay? Bam. All right, now look at this. We went from positive to negative. That's a local max. So f of negative 4.703 is, now I'm just going to go look at my calculator screen. We know that's a local maximum here of 1 and okay, is a local maximum. Okay. Let me go back. Why? Because f prime of this critical value, and don't forget the negative sign like I just did, is 0, and f prime changes signs from, and we're going to go positive to negative at x equals negative 4.703. I'm going to write the corresponding question, or answer I should say, in justification for this being a local minimum. However, I am also on a closed interval. So folks, not only is this a local maximum, but so is, this is going to be a global maximum over here because it's increasing. Okay? Now, this is going to be, at the very least, a local minimum at negative 6. Why? Because the function's strictly increasing here. And you got to think about that. But I only wanted you to look at the relative extrema, so I will let you get away with just that in this case. I hope these two examples were something that you found helpful.